In this video, we'll be learning about infinite sets using roster method and ellipses. So let's start off with this first problem. Write the set of integers divisible by 5 using the roster method and label it with a z. So z is going to be our set name, and our elements in our set are going to be integers divisible by 5. Now, an integer is going to be a whole number, whether it's positive or negative. So there are infinitely many integers, and there are infinitely many that are divisible by 5. So how are we going to represent that? So there's something called an ellipsis that you can use to simplify a set or a pattern. So it's represented by these three little dots right here. So for example, if I wanted to show even numbers from 0 to 100, I would start off with 0, and then I would go to 2, and then to 4. So I have to establish three numbers that are in the set, and then I can use the ellipsis. That way the pattern is shown and it's clear and concise. So then I use the ellipsis to say that it goes on to 100, and then I close my set. Now if I just wanted to say all even numbers from 0 to positive infinity, then I just wouldn't include the 100, and the set would look like this instead. So this ellipsis here is just going to infinity now that I don't have a designated number in front of it. Now the set in the problem, it reaches both infinities, negative infinity and positive infinity, because integers include negative and positive numbers. So how are we going to represent that? Well, we know that's going to go to negative infinity because it's integers that are divisible by 5, and integers can be positive or negative. And numbers that are divisible by 5 can go all the way to negative infinity and positive infinity. So we start off our set with an ellipsis to say that it goes to negative infinity. And since we need to include three numbers to establish a pattern, we need to do the negative side first and then the positive side. So we're going to start off with negative 10. Since negative 10 is divisible by 5, you do negative 10 divided by 5, you're going to get negative 2 back. So that means it's divisible by 5, since you got a whole number back in result of that division. The next number would be negative 5. And then the number after that would be 0. You can divide 0 by 5 and you're going to get 0, which is still a whole number, even though it's 0. And then next we got to do the positive side as well. So we have to include some positive numbers to establish a pattern on the positive side. So we have 5, and then we have 10. And then now we can use our ellipsis again to show that it goes to positive infinity as well. So we close our set here, and that's going to be your answer. So let's start off with the second problem. Write the set of odd numbers greater than 0 using the roster method and label it with a capital O. So our set name is going to be set O. And our elements are going to be odd numbers greater than 0. So we're not including 0 in the set, but numbers that are greater than 0 or bigger than 0. So an odd number is a number that you can divide by 2 and you don't get a whole number back. So for example, if I divide 1 by 2, I'm going to get 0.5 back. So this means that 1 is an odd number. So 1 is going to be in our set. Now if I do a number like 2, and I divide 2 by 2, I'm going to get 1 back. So since I got a whole number back, this means that 2 is not odd. Now if I do a number like 3, I'm going to get 1.5 or just 3 halves. So this means that 3 is an odd number. And then we can do the same for 4. 4 divided by 2 is going to give you 2. So that means that 4 is not odd. And then we do 5, which that's going to give us 2.5. So that means that 5 is an odd number. So now that we have our three numbers, we can use our ellipsis because it's odd numbers greater than 0. Odd numbers can go all the way to infinity because it just repeats this pattern of adding 2 to the previous number. So we can use our ellipsis here and then close the set. And then that's going to be your answer.